Hi, my name is Professor Tulika Bose. I'm an experimental particle physicist. I work at the CMS experiment at the Large Hadron Collider in Switzerland. The CMS group at UW actually has 4 faculty, Professors Dasu, Herndon, Black, and myself. We have 4 scientists, 4 postdocs, several graduate students, and an undergraduate students. What I'll talk about today is really the primary focus of my own research. I would say there are 3 sort of main focus areas. First, of course, physics, the reason we built the CMS experiment. I'm most excited by searches for new particles, heavy new particles, dark matter, etc. You can actually do these searches in 2 different ways. One is by direct searches, so going after these new heavy particles or looking for candidates for dark matter. And in the other way, you could do it by doing precision measurements of properties of standard model particles, such as, for example, the Higgs boson or the top quark, and looking for deviations in the measurements and comparing them to predictions. So my students and postdocs are involved in both of these different categories of analyses. My other focus area is CMS trigger. So at the LHC, collisions are happening every 25 nanoseconds, so at a rate of about 40 megahertz. However, real world limitations, amount of money and resources we have, allow us to only write out of the order of about 1 kilohertz. So somehow you've got to go from the 40 megahertz of input rate to 1 kilohertz of output rate. You do this by virtue of what is called a trigger system, which literally selects interesting events and then decides that those are the ones to be kept for offline analyses. You do this by virtue of a 2-level trigger system at CMS, where the first level comprises electronics, which the UW group has been responsible for building part of. And the second level, which is called the high-level trigger, which consists of C++ algorithms, which are currently running on a form of CPUs, and there are plans for upgrades in the future, whereby, again, you make decisions to decide what gets saved. So our group is involved in both aspects, the level 1 trigger as well as the high level trigger. And we always welcome new graduate students joining this effort. At the same time, we're looking forward to the high luminosity upgrade of the LHC scheduled for about 2028. And the accelerator is being upgraded, the detectors are being upgraded, and as a result, there are a number of challenges, and we need to upgrade the detector in order to meet those challenges. And along with the detector come upgrades needed for software and computing. So part of my research also involves figuring out what are the good strategies for handling these challenges. And this could involve, for example, move to new heterogeneous hardware, such as GPUs, or having more machine learning as part of our computing and software processes. So again, I look forward to having new graduate students join our group and then participate in any of these activities and projects. And please feel free to look at my webpage for more information or talk to me directly.